Okay, this is the lesson for Workbook 21. And the idea behind this one is dilations. They're things that make them bigger or smaller. If you were to have a picture on your phone and you're like pinched and zoomed in and zoomed out, the picture stays the same. It doesn't usually warp anyway. And that's the idea behind dilations, is you're making the whole shape bigger or smaller. And with that, the triangle, like if you had a triangle like this, and so these are the sides, and you made it bigger, notice that the angles, like the angles right here, stay the same. So even if I go bigger, the angles stay the same. So dilations just make things bigger. And with that, the sides become proportional. And this is where it kind of can look very confusing. But the first thing you need to know, let's talk about the angles. Notice here between these two, all of the angles are labeled the same, but then the sides are proportional. So notice if we took these sides, I take the easiest looking one. 4 divided by 2 is 2. And then I double check. Okay, 5 divided by 2, yep, that's 2.5. 3 divided by 2, yeah, that's 1.5. And 3.2 divided by 2 is 6. And so we would say with this one, when we're talking dilations, we'll have a scale factor. That means like the number that you multiply it by in order to make it work. So with this one, we would multiply it by 1/2, which is the same thing as dividing by 2. So for these, the scale factor would be 1/2, which means, again, the same thing as dividing by 2. But if we were to look at these, this is not the same thing, because notice that this is 5, 3, and 4. And so that means that these would have to be different, right? But on this one, it's not even the same shape. 3 and 3, they're not similar. Okay, now we have the portions, so the similarity transformations. So we know about the similarity transformations that make, so we talked about them in the congruence transformations. We had a rotation, a reflection, and a translation. Doesn't matter the order. And now we're adding in similarity transformations. So it's all of those plus dilations. So then this means that the two figures stay the same. So these three, we talked about, those were rigid transformations. And then we add on dilations and it makes it different. So by the way, this is kind of helping you do the workbook, the discussion. It says, imagine a world where there, basically come up with a definition where there is not those, like where these rigid transformations do not mean that it's similar, or the only thing that's similar is if it has to be different sizes. So it's just saying, imagine that world. And with that definition, answer the other questions. Okay. So there are many types of transformations. We talked about those. So these are some specifics. So notice right here, I don't know if you can see my arrow right there. There's the H. There's the center of dilation. That's the point that things grow or shrink from. Then there's also the scale factor right here between H and A, or A and K. With this particular one, notice that A is halfway between H and K. So the blue one is the pre-image, and then the red one is the image. And since it's halfway between, so we have two things that are the same length, that would be the scale factor of 2. Okay, coming back down, the effects of dilations. So they make them bigger, they keep the proportionality, and that's where, again, where it comes in tricky. So this is, let me just show you the idea. When I'm making proportions are just fractions. When I'm making the proportions, I like to use like one thing from one triangle or shape and then one thing from the other one in a fraction. And then equals, and then some other part from the same triangle. So the ones at the top are from the numerator are the same triangle. This fraction, this part to that, a different part. So they mean these are the same part, these are the same part. These come from the same triangle, and the denominator comes from the same triangle. I don't know if that makes sense. So like this, I would say 15.2 over 3.8 equals 21.2 over the thing that's right there. Okay, 5.3. So that's how I would set up the proportion. And then if we didn't know one of them, I do something called the hook, which makes it very easy to do. So do we have an example of using that? We don't. Okay, so we just want to talk about which one of these two polygons are not similar. So again, same shape means similar, not same shape, not similar. So those are the same shape. Those are the same shape. These are not the same shape. These are the same shape. So that's just checking that, and woohoo, we got it. So then here's the thing. Here's the problem. So then, and then the order matters. So we have triangle, let's see, they say RSP is similar to, so we started with R is similar to R prime. S is similar to S prime. P is similar to P prime. So those have to go together. So it has to be RSP would have to go with RSP. It's not the same, not the same. That one is. The order is the same. Next one. Dilation of 7/8. So let me remind you about multiplying by a fraction, because that's the scale factor. We multiply whatever the length is by that scale factor. So 7/8 multiplied by 4. If your brain's like going, well, I can't do this, what you're going to do is 7/8 multiplied by 4, right? Or I guess from your point of whatever, 7/8 multiplied by 4. We would divide by the bottom, divide by the denominator, and multiply by the numerator. Denominator, numerator. Divide, multiply. I say divide by the bottom and times by the top. Divide by the bottom and times by the top. So 4 divided by 8, that's half, right? And then half of 7 is 3.5. So there we go. That is 21.1.